Hello all, thank you for giving me the chance. I am Srishti Shah, presenting author of Rice Disease Detection using Intensity Moments and Random Forest. In my presentation, I will try to cover these topics. Rice is a staple food of almost half of the world's population. Generally, diseases are detected and identified manually, which is very expensive, especially for the remote area, and it is also time consuming. So, the disease detection and recognition is an important task. There are many paddy leaf diseases like brown spot, shed blight, leaf blast, narrow brown spot, bacterial leaf blight, etc. So, severe paddy leaf diseases are blast, blight, and brown spot. In this research, we will chosen the most common and severe paddy leaf disease, like bacterial leaf blight. So, bacterial leaf blight is caused by bacteria. There are some symptoms like it is yellow, straw colored, striped, and the lesions are near the leaf tip or the margin. Here you can see that. Next, leaf blight. Blight is a fungal disease. There are also some symptoms like these lesions are spindle and shaped are elliptical shape and white, and it is whitish to gray center and with red to the brownish center. Then brown spot. Brown spot is a fungal disease, and its symptoms are lesions are usually small and circular circular dark brown to purple brown. There are some application. It is an automatic and robust leaf disease detection system, and it is helpful for both life and economy, identifying names of the disease very smoothly, and it also save crops by this detection process. There are some related work. First, classification of the rice leaf disease using morphological chains. This is an automatic system to classify brown spot and leaf blast disease of rice plant based on morphological chains, whose segmentation algorithm is used to segment the image. This is the this is the boundary of the spot image, and extracted feature are used to classify the disease. They found the accuracies 97.5 and 68.1 for bias and SDM classifier. Monitoring and controlling the rice leaf disease using the image processing technique. Categorize different features such as the color of the affected portion of the leaf and the shape of the leaf. Here, K nearest neighbor and minimum distance classifier are applied. Affected region crop part is under consideration. They found 89.23% classifier for the accuracies in this system. There are also some other works, the detection and recognition of rice leaf disease using texture feature. They remove the texture feature, then categorized cure method for this respective disease. They attain 94.16% accuracy in this system, but they apply in less amount of data. Next, rice leaf disease detection using detection and classification using machine learning algorithm. Artificial neural network is used here to detect the rice leaf disease. K-mean clustering is used to segment the image, and they only use the blast disease here. So the objective of this work it mimic the human task to find the disease correctly, recognize disease primary stage, and with high accuracy finding the disease with the name from the input image. This is the flowchart offer of this work. Firstly, first the image acquisition system. In this process, first we collect the image from the internet, then convert the image RGB image to grayscale image. We extract the feature like 7 intensity, moment, mean, mode, median, mid range, interquartile range, standard deviation, etc. Is used in this process. And then by the existing SAR process, we find that which combination this the result is best. And by this search process, we see that in mean, mode, range, and interquartile range is enough to find the best result. And we also choose the best classifier. We see that in the random forest classifier, it is nicely uh, find the disease. So this is the training phase where image acquisition and image preprocessing are contained. And feature extraction process, firstly image is extracted, image feature is extracted, and then applying the math formula, the feature vector is created here. And previously I explained the existing star process. Here the 127 combination are applied to find which combination is best for what classifier. And next, the testing phase, feature of the query image is extracted. After extracting the feature, a feature vector is created. And and using the row feature and the column feature, they applied a they applied a decision, send it to the decision tree, and decision tree aggregate the voting, and then find which disease is contained in the image, in the query image. This is the big picture of the random forest decision tree, classifying this rice disease detection. The left branch and another branch is just above or equal to the threshold value, and mean, mode, range, and interquartile range respectively denotes x1, x2, x3 are utilized to represent the decision node, and leaf node 1 to 3 respectively represent blast, blight, and brown spot disease. Calculating the majority voting, what type of disease containing in the leaf come out. This is the some sample dataset of the image. Here 2/3 of the dataset from the image are available for training, and the rest 1/3 of the data set is attained for testing dataset. And this is the feature extraction results, where we see that we use the existing feature for different combination. And by this search, we see that mean, mode, median, mean, mode, range, and interquartile range are best for this standard for classifier. And here accuracy is the best, and this accuracy is 91.47%. This is very good. This is some experimental results overview. We see that these are the correctly identified disease name, and in some case it failed to predict the disease. And this some comparison result with another works. There are some limitations. It's unable to detect only the affected part of the leaf disease, and when the disease are same shape, it is result is not satisfactory. This is because we use the interdisciplinary moment in this work. However, this is very rare case, and the proposed method performed quite well in the in PT large scale data set also. So intensity moment and random forest classifier introduced rice leaf disease detection, and it is user friendly for disease classification. And they found and we found the noticeable improvement from the proposed method over the state of the art technique. These are the reference. Thank you for seeing this presentation. If you have any question, please ask. Thank you.